Sala tagliatelle, prova, gelato. Test del gelato. Sala tagliatelle, test gelato.
Is that when you use tools in a non-frequent
Sala tagliatelle,
manner,
test
for
archetto.
example, if you
Sala tagliatelle, test archetto.
just once a month,
Ci sono? Sì.
you
Sala
should
tagliatelle, test archetto.
check on the web the correct syntax.
Well, we already used product.
Nose test, nose test, nose test. Do you prefer PyUnit? No.
20 secondi solo, vediamo. Perfetto. Ok. Shall we?
Ok, menu 1.
Ma sì, dai. Okay. Hi everyone. We're going to start a presentation of Roberto Polli about will iPython replace Bash? Please turn off your cell phones or shut up the ring and enjoy.
Hi everybody, wearing after. So I start, excusing for my English. English speaking people are welcome to speak slowly so that I can understand. Let's start this presentation with what we're going to talk today, how iPython speed up my productivity and help me to improve my Python confidence. I am Roberto Polli, I'm community manager at Babel.it. I love writing in some languages. I started with C, Java, and now I embrace the Python philosophy. I got some Red Hat certification, and today I want to thank my proud sponsor that pay me my hotel bill for being here, Babel. This company where I work delivers large amount of infrastructure based on open source software. So, let's start with one assertion. Bash rocks. It really rocks. If some of you started working with the C shell or with Korn, knows how Bash rocks. So we'll see some simple example where that Bash covers and that some other shell node, even iPython. And we show some simple Bash patterns. Then we see a small comparison between Python and Bash, the strength and the limits of both. And at a certain point, we ask ourselves, okay, this Bash job is going to start to be problematic. Can Python save the day? This is, with this talk, I state that even system administrator that doesn't love programming can gently learn Python and in the same time being productive. They don't need to just waste time theoretically, but they can do productive things while playing. And then we see some real-life scenarios using fields of an output, parsing some proc files, start reusing stuff. This is a great advantage with Python. You can take your history with some modification, put it in Python modules, and then they started this way and they became a library. How to use Flask. Flask is a very nice micro framework that allows you to create a simple web application, or web application in a simple way. And if you need to expose some monitoring stuff, for example, the memory status will see the memory status of a computer and will write a script and expose it with less than 5 lines of code to a web service. And then we'll see nose test, that is a nice test framework that even people that is not interested to learn how the Python testing framework works, to write some tests in a very efficient and simple manner. With Python, you can manage it faster. So, Python versus Bash. Bash is the shell, and Python is the web spreading system language. Why don't find a reunion? I made this snippet for a Python course. It's provocatory, but let's have a look. Which of those scripts do the same things? Which is more readable? On the right side, it seems just like some Perl voodoo. Actually, that is the correct way to use Bash. If you use Bash and don't use another shell, it's because you can lower a variable without using sed. You can split and replace without doing echo pipe sed. But this is more readable. If I have to pass, during a course, a man told me, hey, I know Bash. I work with Bash from 5-7 years, but I don't understand what that means. Okay, well, is there somebody that doesn't cover Python at all? I think even if there is, he can understand what does that snippet do. So this is one point for switching part of your work to Python. Let's look at the fortune of Bash. What does Bash do? What does it do right? Bash do right job control. Because, well, if you run Bash, except for some fork bomb, Bash doesn't host.fork. So everything is quite linear and manageable. Bash can do very nicely simple pipelines. So we just exploded this zip file in the wrong directory, and we just want to remove the file we just added. And even more useful, a clean I/O redirection. The first line is just a simple Kerberos login. Does the following: create a temporary file with the string secret inside, and then pass it to the standard input of the preceding command, and lately delete the temporary file. Okay, just all these in 3 characters. Okay, this is really useful. And the second one is just like a common standard in and standard redirection. Bash does it very well. Another one, brace and globbing. I can create with one line 20 temporary files for testing, but beware, bash 3 behaves differently from bash 2. It may create 1 to 20 or 01 to 20. So those commands behave differently. A nice thing of globbing on the first line, another feature is really cool. History and real-life substitution. When you type something in bash, it's first parsed and modified by the readline library, and then is interpreted by bash. We'll see this after, but it allows us to do the second line, just global substitute on the previous command, foo with bear. So this is a very nice shortcut. We can type long commands. The fc built-in bash built-in opens our favorite editor and let us write our command, and when we save, it will execute. So those features are really useful, and they made a difference with previous shell. What do we want to achieve? Where we can improve? Well, safe system scripts. Well, if somebody works with bash, knows what the first line do. When we create a file with the dash behind, the bash globbing will add that string to the command. So the rm star will remove the directory too, because it becomes rm minus rf and so on. So this is really an issue. It seems stupid, but if you look at scripts that you find on the web or of some colleague, you'll find rm star, and that's evil. Readability. Everybody knows what those 3 lines do. This is an old way of doing things. This is the World Taekwondo Federation. And many people which I speak to tell me, okay, Python is more readable, but hey, bash scripts are shorter. And then I ask them, are you really sure? Are you really sure? Because do you have RM on your PC? Okay, RM you'll probably find, but replace with another long command which won't stay in the slide page. You should check if you have the command, and then you have to use that strange array notation to avoid that files with blank lines inside will be managed strangely when you do stuff like exec, eval in the rest of your scripts. So this file could be a simple rm --star, but actually if you want to take some control on the file, if you want to put it in a procedure, we'll probably should log. I'm going to delete this file. This file has been deleted or not. And this is going to start to be weird. For example, we should even check the error exit code of the command with the man page. We should see if the rm failed for example, permission issues, or should exit because the file does not exist. There are 2 different exit codes. thanks to Python exceptions, we have it for free. Another issue, code consistency. Bash 3 that you still have on, well, at least on my customer legacy system, there is both Bash 3 and Bash 2. Is different from Bash 4, so maybe you just prepare a script on your PC and it plainly doesn't work in production because not only Bash version is different, but because AWK version is different, grep version is different, per version is different. In using a more comprehensive language lets you just check one version. Python 3, Python 4, 2.4. But what 2 is given. Let's look at this simple comparison between Bash 4 and Bash 3. Bash 4 with double square lets you implement regular expressions. And another nice redirection stuff, pipe and commercial E. With Bash 3, we should echo pipe grep and then make a further redirection with redirecting standard errors to standard output and then grep. So those are small difference, but if there is 2 or 3 people working and you need an assessment not only on the code but even on the feature. And actually I found that many people, many Bash users didn't know or the feature or the difference between the versions. And this could be an issue because when you go in production you should recheck everything. It's one more step. So those are some wishes. Let's start with plain Python, just the one you have on your PC. CPython delivers an interactive interpreter with limited read line and history support. Even if you go up and down with arrows, it means that usually there is libreadline that is parsing your input. So things are going to be good. But differently from Bash, it requires parentheses, string quoting. On the other side, it has batteries included. You got Python, you got Telnet. Did you ever install some hypervisor machine? It's just really bare metal with a kernel and some virtualization libraries inside. You don't have Telnet, but you have Python. So if you need to Telnet, just Python -m telnet lib and you have a Telnet client. The same is for other libraries included into the Python standard library. So even on Solaris, I needed to make a simple MD5 hash, and there was not the command installed. Okay, I told to my colleague, stop, check if maybe there is Python. You have Python, you have an MD5 function to use. So it starts to be everywhere, and it's going to be useful, even to people that doesn't seem interested. Maybe some of you do know, I didn't know, so I share. CPython shell can autocomplete. Just use this line because this bind is the secret. It's just like the bind built-in in Bash. It tells, it configures readline. It configures how to parse the input string that you pass to the interpreter. And then even if you are some strange machine with nothing installed but Python, you can autocomplete and learn, try to use Python libraries, even if you doesn't know them. But there is a shortcut. You can use iPython. iPython interactivity plus equal 1. You can do plus plus in Python. It's easy to install. It comes in various flavors. You can use just a vanilla iPython interpreter. You can use a prepaid environment with a lot of mathematical function, or you can use my favorite one, the one with some shell built-ins. You can configure it with this simple line, and you can customize prompt, spacing function, shortcut modules, and almost whatever you want. You can even mess with the code because, hey, it's in Python. You got the code and you don't have to rebuild it. Okay, why I like iPython? It has a shell pass-through. If I just type a command which doesn't conflict with the global scope or local scope of Python, it just executes. So I can ls, I can use alias. Actually, the version which I have on my system for this kind of stuff uses os.system. It can capture both standard out and standard error. Just use a bang before the command. Actually, by default, it doesn't split. So you just have standard out, put a standard error on a subsequent string, and it is put into the ret variable. And you can get exit status, which just resemble the bash standard exit status. A couple of things. The output in ret is a flexible object, an iPython slist object. This slist object can do some useful things that we are going to see. Beware, exit code, this one, might not be exactly as expected. I found in many cases, but my fault, I didn't dwell exactly a lot. It's just a 16-bit shift. So if you have 0, you have 0, but if you doesn't have 0, you have to shift by 16-bit. So, some features. Just like put ret and get my resolve.conf. Just 2 lines. When it represents the string, the object, it seems just a list. ret.s is just a space join of this list. ret.newLineString is just a /n join of the object, and this is a good starting point for parsing a scripting. You don't have to always reiterate writing the commands, waiting to find the exact syntax of Perl and AWK if that regular expression requires to protect with backslash the plus sign or not. You just have the output and you just play directly with the output without always retyping and retyping the same things. iPython has various magic. There is the autocall magic, the edit magic, the debug magic. Everything starts with a % is just adds functionalities to the shell. If you type % autocall, you are just telling IPython not to require parentheses around functions. So ret object as a grep method. But instead of stating ret.grep parentheses quoting bubble.it, you can just enable autocall automagic stuff, use the comma automagic to tell to stringify the passed objects, and this transform this string in ret.grep parentheses quote bubble.it. So this is starting to resemble a shell behavior. So if somebody tells you, okay, I love bash because I don't have two quote strings, you should tell him two things. One, always quote even in bash because space exists. Second, actually, if you don't want to, you can do it even in IPython. Expansion. Okay, we can pass Python stuff to the shell, just use the braces. We can get the PID output and put into the ret variable. Consider the following steps. IPython parses the line and expand contents in braces. Prepare the command, fork exec, and the shell interprets the commands. So beware, look at this. The star is interpreted by the shell. Parsing system files, we just get the current process memory status, and we can replace AWK with fields, the fields method. We can fields 0, and we get the first. We can move the columns. We can use range star magic to get a range of fields, and we can get the last fields independently of the length of the lines. To unpack data, we can make a simple function. This function get a key value string and put it into a dictionary. So this becomes key, VM peak, key values 27,308. Okay. Fill this function is more generic, and I just put it into a file and put it into the IPython profile startup directory, just like you do in etc profile.d of Linux, and you can add all your functions. And then let's see a simple IPython script. Just use IPython like shell and use .ipy as extension. I got fields. I got sleep. Well, tonight I sleep a few. We can grep directly and get the output. So you can still use bash stuff. We can convert it into a dictionary and format with the Python string format. Okay, so it just gives me for each line VM size, VM resident size, VM swap. It's really short, it's very readable, and well, you can just use it into your in your shell. Watch out some pitfalls. Beware of bash expansion and substitution. First, IPython replace the dollar function. This is a Python variable. Python replace this variable if it exists in its scope. For example, if fn equals cwd, then it becomes this one. Then there is a no system So this bash shortcut is going to be interpreted in the host system, in the forked environment. So if you want to get the actual command line, you cannot do this into iPython. You should expand at Python level. Clear? Expand early and in Python, unless you know what you're doing. This is the good one. This is the evil one, unless you know what you're doing. Okay. OS system uses bin shell. So this does not work because bin shell doesn't support pipette. I used a quick and dirty solution that is just edit this iPython file and add the executable parameter to the subprocess function. It's really easy. Somebody asked me, why don't you use OS environment get shell here? So just use the user shell. Okay, I am pro, I could use it. But there is people that doesn't trust OS environment. I think those people shouldn't use OS system too. So, okay, everybody uses edit threshold. Plotting system data in 4 lines. A system administrator must plot. Collect data. Okay? This line takes the 7th field of the output and grabs with the string time. Okay? Then it's just like takes the second part after the equal, because fields just split by white space. Okay? And show. Really, it's that simple. And you have a distribution of your round trip time on your system. Okay? I think this is important, but I find people that is not interested in plotting. Strange. Flask keys. Scripting with Python, you'll collect a lot of useful snippets, because everything you write, you can retrieve with the history magic. And actually, it's really easy to get the snippet and put them into a script, or maybe let them become a library. Flask is a web micro framework. Everybody knows Flask here, at least for the name. Okay, so this is a sample script. Just like you just have to use the root decorator. Tell which is the address you want to. Oops. You want to register. So when you make a call to localhost /memview/pid, it returns a string of all the VM stat of the machine. And really, you have a web server exposing one service. You can reuse the EuroPython library, that the field is function that you put in your iPython stuff. Actually, can't use the bang command syntax with Flask. At least I wasn't able to do it. I think there is a problem with the forking, because, well, here I am using just like a embedded container, so there is a process, you are listening sockets, so you are forking. Okay, nose test. The 3 simple steps. Put your test files in a directory, run them, knows, discovers, and runs them all. Really, it's that simple. Here, there is a small script that pings to machine and use TCP test on the 80 port with a 1 second timeout. With ICMP, I should use host.system or exec because ping is as the suite bit set because ICMP requires root privilege. So you'd better, it's faster to use host.system. And okay, when I run nose test /test, all those tests are run. If I put even more files, nose will auto-discover them by the test name of the function and will run them. Really, it's that simple. 2 bonus tracks. iPython autocomplete helps learning new API. Just a simple example, the OVIRT, open source virtualization infrastructure, and the 389 LDAP directory server. We can just install, this is installed from iPython. And here I'm just importing the API, logging in to my virtualization infrastructure, list all the machines, stop them, and log exceptions. Okay, I stop maybe 100 virtual machine. Okay, I should make controls and so on, but okay, I am in a hurry. I need to leave now and I want to shut off my virtual machines. That's it. 4 lines. If I don't know how to use it, just type tab and you'll find VM and find list. VM.get tab name, it tells you. And then create my directory server. Just clone that's not mine. It's a library that very rocking people have read out right for testing, and I just take it and started to organize it, and they were so kind to let me do it and merge my patch. Use it, enjoy. If you use 389, it's a good hit. Just connect to the server. Do you need to configure the directory server to use SSL, but you don't know how? Don't do it, but if you still want to, just type setup SSL and it is done. This was the weird old name. Okay, don't you remember? No, iPython with autocomplete. This gets the replication status of the directory server. But my development release includes method name refactoring, so you can just type ds.replica.status or .agreements. So, well, tab can always help. And then, the answer. Will iPython replace Bash? Not in the near future. Mostly because, well, Python is anyway a lot of stuff. iPython is even more a lot of stuff. So I think not. But iPython can lead to a different use of Bash. Using that simple snippet and replacing bin shell with Bash, you can still have all your Bash magic into iPython. And that's really useful. And I think, my opinion, iPython will complete with weekly interactive tools like Perl, AWK, and SAD. It's a tool, surely a tool you shouldn't miss. So, okay, that's it. Hope not to have to be boring. Hope you enjoyed. And well, again, excuse my English. And have a nice day.
We are sorry, but now we are out of time. if you want question, I'm afraid you have to seek for Federico Polli around. And well, yeah, I'm sorry. This evening there shall be the pie barbecue, and if you are celebrated, don't forget about it. See you.
More comment. Do you know PyTest?
Excuse me?
Py.test.
Py
It's a
dot-
library like Nose, but better. Check it out.
Sì, 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 sì. You're right, prendo il my stuff.
Sì, sì, beh, certo. Well, you have 5 minutes.
Great talk, really enjoyed it. Very nice.
I really happy. It's to me it was quite difficult because I'm not a Python expert.
You explain things very
Non si dice, cioè non si farebbe il paio saluto Callando, è vero?
Che?
No, nel senso tanti esempi, spiegato bene perché è una cosa, una parte, ho capito molto bene.
No, quelli,
Ho panicato un po' perché stai pensando che provassi, però a parte quello...
no, c'era quello che mi diceva che non sforava. Oh, ci vediamo dopo, dai. Oh, grazie per tutto il service, vi fate un mazzo tanto, siete andate veramente una spada.
Stai parlando del microfono?
Sì, ma mi piaceva, caspita.
Allora aspetta, lo mettiamo muto. Tagliatelle, prova microfono gelato. Tagliatelle, prova microfono gelato. Hello? Ok, sono good.
Testing 1, 2, 3, testing. Testing 1, 2, 3. Okay, that sounds like it's working. Right. Is this the highest resolution it can go? Or can it go any higher?
Sorry?
Is this the highest resolution?
Well, I don't know, I never use a Mac emitter. No. This stuff accepts only resolution of 1024 times. Okay. It is 60. That's the one. Stiamo sempre parlando del lacchetto di tagliatelle, non mi sentite? Oh. Ah no, ok, it's exactly as expected. Tagliatelle proprio di aria, vedete? Pochissime. We are already late, he said. No, non fate pulito ancora, scusi. Prova archetto del speaker di Tagliatelle, prova ennesima. Tagliatelle, ho fatto la prova dell'archetto e continuo a fare la prova dell'archetto. Ricevete o non ricevete a Tagliatelle? There is the coffee break after, so there shouldn't be a problem if you waste 5 minutes. But still it's so annoying, why they don't tell me something? Tagliatelle, lo ricevete l'archetto o non ricevete l'archetto? Sto parlando? Oh, fine.
Right.
What's your name again?
Gemma Hench. Just Hench, yeah.
Hi everyone, we are going to begin the presentation of Emma Hench about using Python in the modern war. Please listen, turn off your cell phones and enjoy.
So, unfortunately, now I've actually got you here, I do actually have one teensy-weensy confession. Although this code could be used in the war zone, the environment I was using it in was event space stuff. So, it's a very unfriendly coding environment, and it was described to me as a war zone when I started working with it. And they weren't wrong. It wasn't quite as bad as they initially indicated, but it was okay. It wasn't okay. It was stressful, crazy, and exactly how I would imagine if you're trying to make your code survive in very resilient, problematic situations. I dealt with 3 main problems, which I'm going to try and summarize as much as I can into this space. One of the biggest problems we suffered from was the fact that we had you're opening up a connection and then you're closing, opening up another connection. And I thought, well, and what you need to do is you need to keep the connection open, and then you can have, and then you just send messages down and down and down. So rewrote the software to do this, and then when it went live in New York, in the middle of a press event, the system crashed, and I had no idea what was going on until I realized that's not how the system works. Their system just doesn't know how to send messages back properly, and they think it keeps connections open, but what ended up happening was, because they kept my connections open, I ended up having about 10,000 TCP connections wide open, and the system did not like that. So that's that. I want to try and make sure that I've left enough sides to both sides, so I want to carry on with the other side of things, which is more, and then I'm going to come back to if anyone wants me to talk a bit more about networking, I can come back at the end. But the second issue is, I think, actually one that's more directly applicable to people, which is the problems of, well, there are lots of ways to describe this. I start talking about lightning, because the most apt example I could think of this was when the supposedly wonderfully stable, bulletproof, rock-solid US 1 class availability zone of Amazon went bang because they didn't think about Mother Nature. And most of the stuff I've done with this involved where you can actually have somebody put a spade through a power line, or a network cable, or somebody, when they were tired, accidentally yanked a cable back out of the back of a server because they were working behind it. No names will be mentioned on that one. And that person had been up for about 40 hours and was very, very tired, but we will not mention that one again. But to a certain extent, this is still a real problem, even in situations where we're told there is reliability. We're told these situations exist. One of my first disaster situations was back in about 2007 when I was working for 2006 when I was working for a very shady e-commerce company. And I don't know if anybody was in London back then, but there was a massive power fail over, and one of the major data centers in London, their systems didn't work, and we lost half our data. Now,
Backups, right?
shady. Actually, that was the time I learned how to do .NET, because they didn't know how to do .NET, and we needed to fix some code. So it's not actually that difficult. I mean, at least the language isn't that difficult to understand. Never put .NET in your CV either. Even if you think you understand it, you will be bothered for the rest of your life by recruiters trying to say, "But you can do .NET." No, I was using that as an example of my flexibility. I do not do .NET professionally. But, so the issue here is not so much the reliability of the hardware or even the operating system or even your software. That's not what we're talking about. The problem here is what happens with your system when it comes back from the dead. And to be honest, I am very much a fan of building state machines in my systems. Not always as beautifully and elegantly as I'm sure my computer science professor would like it to be, but that's actually what I've done in most of the systems I've done in these situations. And also, it's just I find it's a useful, helpful pattern for doing it for dealing with multiple systems talking to each other. The trouble is what happens when you're coming back from the state, or you're coming back and you're halfway through two states, and your system doesn't know how to recover. What you've got to look at, I mean, my initial route was to make my system as reliable as possible. I was using a combination of Redis on write everything out before you even admit you've got it mode. And the other, because I don't know if you guys have had much experience with Redis, but there's, at least at the time I was doing it, there were three modes. There was the, it's in memory, you shouldn't really be relying on me. The, I will write this out every second, and once I've responded to it, I've written it down. Once I've got the message, it's written onto disk, which is a good way to get started, but it still doesn't deal with every situation. And the other method I was using for one of my other areas was a RabbitMQ backed Celery. And I have to say, RabbitMQ is, I literally yanked the power cord out of the back about 10 times and just saw how the state was, saw how it was maintaining the state. Every single time it came back from the dead without even so much of a complaint. But even then, if it's in between these states, you've got to think about how to do it. Now, I have some bad code, and I have a lot of notes about how to not do this in future. So, well, I mean, there's various solutions in the way to do this. The most reliable way I found to do it was you actually had to almost think about it a bit like migrations, in the fact that you always had a rollback state. Actually, I suppose it's even more like you just talk about. Sorry, I get distracted in my head way too easily because I start thinking new ideas. What you've got to effectively do is say to the system, when you're initiating the states, that you effectively have a entry state and an exit state to any situation, to each state change. And that any changes that happen in mid-state are not effectively on the system, sorry, it may not be as close as I think. So, okay, I'll roll it back to a slightly simpler thing. If you have your states set on the system, if you have your state set on the system, you don't remove the old state marker and the old state until you've actually completed the state. The final step that sets the new state on the next stage cannot be set until the previous state has been done. So then even if you're halfway through whatever is going on, everything should be written in such a way to, if it stops halfway through, if literally the ground falls from out beneath you, and you come back again, you can still start from the beginning of the state change. Now, I'm trying to think of it. I do have some, as I said, bad examples of this. I mean, this is my, this is actually one of my state machine. It was using Redis as the persistent state between about six different pieces of code that were running in parallel, or running for different components of it, and it's actually using some networks debugging stuff as well. Is that the one I wanted to use? Yes, that is the one I wanted to use. And actually, what I was using there was actually putting flags on the different. The flags were actually a composite of the state. If you in this one, which is a very simple situation, you had. What you have to imagine is you've got a Final Cut type timeline that's actually being live played. And from that, at certain stages, certain messages are being sent from the system that this is handling and passing to other areas of the system, and including making some decision making. So in this one, this is actually a much more simplified version of the code because I took out all the stuff to do with the video stuff. There's video editing, there's messaging, there's messaging going to, there's stuff going to YouTube and everything else like that. That's all been taken out of this, just trying to limit it back to this basic situation. And you've got all the other services looking at that single the Redis instance for the. I'm just actually using it as a persistent key value store that can be accessed from every system from these different systems, but. What I've tried to do here as much as possible is when these state changes happen, they're being limited. If one of them doesn't work, then it should have got to the next state change before the next state has happened, before a crash has happened, because I'm trying to keep them as small as humanly possible. Unfortunately, this is what happens when you don't. This is actually this is a small part of one of my reverse engineering projects I had to do, which is an After Effects. Basically had to reverse engineer After Effects to be able to be a remote image composer. I didn't make this decision. This was what I was told I had to build, so I built it. But to a certain extent, one of the problems with this system was the fact that the whole system wasn't a state machine. This actually worked fairly well and was fairly reliable. The trouble was the machines that were talking to this, because there's other lines of code which I can go through if I have time. It took messages, took a UDP message, and then which would then contain information about how to do a composition. But from that, and then when it had the composition, it would then transmit that message back again. There's a very big trouble here, the fact that the other machines were not operating on the same principle, that it was asynchronous. And as a result, this beautiful system, it worked. I mean, we had problems, but it worked. But part of that is literally a case of you've got to make sure the fact that if you're going to make you have to make these assumptions. You cannot make assumptions about other parts of the system following the same patterns as you do. How are we actually doing for time? Ooh, a little bit quicker than I planned to. Right. Let me think. I was drastically worried about running over, because talk and talk and talk and talk, and then it's normally your job to kind of tell me you should have finished 10 minutes ago. So I was trying to keep myself a little bit limited. But, so I guess the next thing to cover, I suppose the next thing is I could, sorry. As far as, sorry, I suppose the best thing, and hopefully this will be the more useful stuff because it will be more related to you, what you're interested is to how this applies to what would people be more interested in seeing more of? Would it be more about the state machine side of things or more about the networking side of things?
State machine.
Raise some hands.
Okay, so
Separately.
more networking? More state machines? Okay.
Guys, we need more hands.
Okay, so we're going to have to... So... Let me see if I can pull up... This one... Come on. Right. Oh, that's what does that. Right. That's what I was looking for. Okay, so this, as far as going to the networking side of things, this is actually one of a slightly more. This is a implementation of.
Use that.
Right, this is actually an implementation of what I was talking about, of reverse engineering a badly documented TCP/IP protocol. Or API. This is my original notes. Well, this is all I had as far as documentation went. And from that I had to kind of guess what would change states, played around, built a few of their control systems, and then began talking it to see if I could work out what it was. This does actually fully implement the API, but however, a lot of this we never actually ended up using, but it fulfilled it enabled the facility to work. This is the fixed code. This isn't the stuff which kept keeping connections open. But so what I ended up doing is, because it was a very simple messaging format, just do a wrapper for each command, pass it through to the messaging system which is trying to talk through, and this wrapper was actually implemented by several different parts of the system, because all of them were capable of talking down to the compositing system, but sorry, not the compositing system. Sorry, my brain is... I apologise for my speaking. This is actually the first time I've been speaking, so it's also the fact I'm incredibly nervous, hence why I keep stammering and stuttering. This was actually... This interface was actually, I implemented this actually as somewhat of an interface that was then implemented by the web interface that was being controlled by the people on the stands, the messaging system that was being talked to it was receiving messages back from the watch out software, which is the LED control software, and also there was another bit that was handling RFID calls, because people had user accounts. So, for example, they could see. They were able to have personalised information. So, for example, there was all these things. So, if you had your name, it would say, "Welcome, Gemma." And actually, if I get a chance, at the end I will show you actually what the end product of one of these was. There weren't really any issues on this one once I'd actually figured out how this was going to work. The main weirdness was the fact that I was working on the principle, the fact that there was no documentation of how the system was meant to work. I mean, that is what the documentation said. That's all I had to work with, and it was a lot of guesswork from that. incidentally, this is more documentation than I had when I was working on After Effects. Which who have actually, well, admittedly I was breaking in every unholy way to make it work, but when you have an XML format that somebody's going to think about using, you should probably document it. So let's see, where's the next bit I was going to do? So what I was going to do was just talk about, show you the TCP implementation. Sorry, where are we? Okay, so this is actually show you the differences, and to be honest, they are they're both implemented. These are both primitive servers. There is both forking and threading servers also included in the system. These are all in the Python-based library. But this is just I was just trying to focus on the most basic parts of it. So the main difference between TCP handling and UDP handling is that you're dealing with a stream rather than a single packet. If you're dealing with UDP and you want to send more information, you can certainly send more information, but you're going to have to build it on top of that. It's not the response. There's a reason why people use TCP and don't each time try and reinvent the wheel when they want to send much more complicated information. Although UDP does have its advantages. I've been having some fun working on at least a theoretical principle for using, I don't know if you guys have seen much on UDP acceleration. Sort of, if you're involved in content delivery networks, it's one of the hottest properties because it's all involved in how can you maximize your bandwidth for sending files around. And I think the last time I had somebody trot out a solution, I think it was something like 10,000 a month to use the software. But you're dealing with huge files and basically major media companies. So I just think more which is the best thing to show for the next state machine stuff.
I'm curious if you're talking about state machines, if you maybe have an example of when you ended up with corrupted data after a crash.
Can you please repeat the question for the word?
Pardon?
Can you please repeat the question for the listener outside?
Sorry. The question was, any examples of when I had a state machine and I had corrupted data? Actually, for the most part, we were fairly lucky, but part of the luck was that aside from on our press day situation, we didn't really have any mission critical data. Although what ended up happening was actually maybe if I show you an example of what we're actually producing from one of these bits of software, it would actually be not that one.
That's the rich video then.
Let me see. Right. There are about 1,000 of these for Detroit, 1,000 of these from. Actually, wait a second. Better than that, I will show you the. The trouble is, I do actually have one with me in it, but it was done in Beijing, and the person who re-edited the video for Beijing, I want shot because. You'll see what I mean. You'll see what I mean in a second. Right. Fortunately, let's make this full screen. Oh. Which network am I on? I'm sure I'm on the. Oh no, I'm on the. No wonder I'm on the.
It's a good example of network congestion.
Yeah. Right. Okay, now we're in business. I'm being risky. Right. So this is one of the part of the user customization aspects was the fact that the name, if you had your own registered account, I'm not responsible for video compositing, by the way. was controlling all the system doing it. So the worst amount of data problems I had ended up being when we actually had news crews on the stand seeing this. And the whole process of this was once the video had been recorded on another box, which is also being controlled by the same software, and then it was meant to be put in another Celery queue that was being pushed up to YouTube and then attached to the user's account on the card. Unfortunately, this didn't work on press day, and then we ended up having to work through about 500 files to find the originals, cut them, individually produce them, and then push them back up to YouTube again, which was fun trying to do.
Was there a journal in place that
But-
you could refer to?
Pardon?
Was there a journal in place of operations?
To a certain extent, this is another issue of not running other state machines. Other people not running the same state machines. My system knew everything that was going on, but to a certain extent what it said was start recording a file, stop recording a file, and you get the file name back again. If that doesn't happen, my system didn't have any way of knowing what was going on the other side, because to a certain extent it was another blind machine, his primary response. To a certain extent, a lot of this stuff comes from when I was first told about this situation that we were going to deal with, I designed a system that was inspired by the people who, I presume most people have read Rendezvous for Rama? Rendezvous for Rama by Arthur C. Clarke. To a certain extent, it basically described a spaceship designed for moving between star systems, which had multi-layers of triple redundancy. I went to one layer of triple redundancy, and then I was told, no, we don't have the budget for that. Tried for double redundancy, still didn't have the budget for that. So, to a certain extent, there are idealized ways to work on this system, this situation that a lot of these situations shouldn't have happened. But to a certain extent, when you're working in about 3 months to build this stuff from absolutely nothing, you just get it's not possible. So, you can try and minimize the issues by clever planning. You may not always be able to get something that is you may be able to get something that's 99% perfect. You probably cannot get something that's 99.99% perfect, but you can definitely get better than 75% perfect, which is kind of where we started in this principle. So from there, I'm trying to think what else to go on to. So I have managed to be quite quick, a lot quicker than I planned, but obviously the third problem in this situation is the fact that there is a finite limit to how much caffeine you can actually drink. That eventually it stops working after about 40 hours, stops working. I guess from there, has anybody got any other questions? I've got two. Sorry.
My question is about why you decided to use Python instead of any other language?
To be honest, it's one of my. I think the nicest features about Python is it's very good glue code. We had a lot of a lot of hardware that's being written in. I mean, we had stuff that was talking to GStreamer that was actually being interfaced through using a Python wrapper into Twisted that was talking to me. That we had. I built these network libraries. The initial versions of these I built, I think, in 2 days. I obviously went through numerous iterations to improve it, but it's a very quick language for building the glue code type far more complex, far more customized and optimized systems together, and to try this stuff out without. I mean, when you can actually do this stuff when you can do this stuff in iPython as the previous person was saying, you can develop this stuff. You don't have to compile stuff. You don't have to try. Oh, maybe I got the wrong setting. I've got to go all the way back to be. You can literally play around with live code and try and build this stuff and even also debug it. I mean, I've used an IDE with every language I've ever used except for Python. I use a syntax highlighting text editor, and I use iPython. There's been probably only one situation where I wish I'd had an IDE, and that was mainly because the search function on TextMate was rubbish at the time. And it's not always the right tool for the right job, but in a lot of situations it is.
Hi, thanks for the talk. I noticed you used Celery, which is a task queue combined with RabbitMQ.
Yes.
Did you run into any serious limits while using that?
Celery, no, we did. Well, I'm just trying to... Actually, no, because we were experiencing some network traffic issues. So what I ended up doing was I ended up writing scripts to basically try and overload my compositor in every way I could possibly conceive. And I probably loaded 10,000 composition jobs onto it in about, and literally all that was happening was, I can actually show you the code that was doing it. If I can just pull it up, I've got a window. Where did I put that window?
No, I mean there were no significant problems with race conditions, maintaining state across nodes.
We didn't. The configuration we deployed never had multiple nodes. I built when we were looking at the system being a bottleneck, which it didn't turn out to be. One of the solutions I worked on was literally using a single RabbitMQ instance and using several nodes to do the composition, and it handled it pretty transparently on the test runs. There are other backends which, to be honest, there are certain situations when even the SQLite backend will work just about. The Redis ones had a lot of work recently, but the most reliable one, as I said, I was literally trying to break this system and yanking cables out the back of it. RabbitMQ kept it, did what it was meant to do. So, any other questions? Oh, sorry, was that? Yeah, thanks.
No worries.
Okay, then that was it. Now, in the 10 minutes or so, we'll start the coffee break. And I want you also to recall this evening there shall be the pie barbecue. Anyone who bought the ticket is suggested to come. And and I should speak a lot. Well, that was it. Thank you.
Thank you, and thank you for coming.
Congrats on your first talk.
Thank you.
And I noticed you were nervous. I've given a couple of talks myself, and I understand. If you give a talk which has a lot of, if you would like me to give you input.
I would love that.
Okay, because the subject was very interesting.
Tagliatelle. Tagliatelle, sto resta di fronte alla telecamera. Tagliatelle, prova del microfono gelato. Tagliatelle, prova del microfono gelato. Tagliatelle, prova del microfono gelato. That's yours? Sure. So let's see. Let's switch it on. Let's make it on. And
Testing.
sounds good, but
Perfect.
we have to ask for the directors. Tagliatelle, prova microfono archetto. Please talk.
Hello.
This is a test.
This is a test.
I'm Billy Mays.
Hello. Testing. The test. Hello.
Tagliatelle, avete sentito lo speaker parlare nel microfono archetto? Okay, it's true, there are 7 different rooms, and they follow everyone at the same time. That's fun because they say, do the test, start doing something different.
Oh, where'd that come from? Oh.
Please come here, sorry. Tagliatelle, prova archetto. Hi, this is the, don't know English word. Anyway, that's the speaker microphone. Do you hear me?
No. No, they can't.
Well, let's just assume everything works. Hey, finally confirmed. So, last things, if you want to shut it up, the mute is here. You see the black, white, no wait, here, the white
Okay.
trigger. And, tuck, now it's muted. You know.
Hello. Testing. Perfect.
And yeah, that's about it. I will use this one for the questions. If any person does a question when without the microphone, please repeat it for a word.
Okay.
And I'll be happy to remember you if you forget. And well, yeah, that's about it.
Thank you.
I go take a coffee. extra water if you need it. You also had the extra water.
Got some extra.
I just see a tweet, indentation wastes space on your punch cards.
So, io... Dimmi. Tagliatelle ti sente, dimmi. Ah, non sono sicuro. È a posto adesso? Well, you have space to move and I'm getting a pace of the camera more or less from here to here. More or less.
Okay, perfect.
I don't know if you need to move or anyway. That's it.
Well, I'll stay within this area.
Come again?
I'll stay within this area.
I mean, if you want, we can make a tighter zoom on you here if you don't want to move. I don't know.
I will be here most of the time, but I will be moving slightly.
So it's okay. Perfect.
It's fine.
Okay, 5 minutes left. Questi nuovi sono fantastici.
L'unico modo con cui un computer del 2008 può essere ancora usabile. Un disco SSD.
Attaccarci lo sticker.
Attaccarci lo sticker? Sì, sì, sì.
Io ho visto lo sticker bellissimo della vecchia mela, sai quella colorata?
Sì? Geniale.
Quella è molto carina.
Ravioli.
Oppure sto cercando qualcuno con capacità artistiche per disegnarmi. Non so se hai visto, hai visto sicuramente quel quadro di Monet dove c'è questo uomo messo così con la mela sospesa sulla faccia.
Ma quelli si trovano su Etsy, quelli già
Sì,
fatti.
lo so,
Però sì, chiaramente è disegnato
Allora, facciamo...
in effetti.
Vedi? Yeah, one of the cool programs show you an extra slide.
Oh, it's very useful.
Yeah, yeah. Also, LibreOffice now does this. That's
Oh, right, I haven't used it. Oh, fantastic.
Yeah.
All for free.
And also, for PDF presentation, there is a PDF presenter console program. That's a similar work. I use it for my thesis presentation. And it's very useful.
That's fantastic.
What's this?
That's for,
Oh, it's an external keyboard.
yeah, just so I
Minimal
can move.
keyboard. Keyboard with keys you need and nothing more. We have 4 keys now. Top
Oh,
and
just need up and down, really. I don't even know what this one does.
Oh, we have 30 seconds and we'll begin. Russell Sherwood.
That's right.
Russell Sherwood. So it's not Russell though. Russell. Anyone has any idea what this pen are?
They're from us. So they're from us. There's just pens and little seeds for people to take.
So we should wait for these guys?
Oh no, they don't belong to anybody. They're just for people to take.
Oh. Free stake. Okay. Okay, I guess we're coming in. Yeah, sorry. Tagliatelle siamo pronti a partire. Tagliatelle siamo pronti a partire. Hi everyone. The presentation of Russell Sherwood about agile development is going to begin. Please switch off your cell phones and enjoy.
Hello everyone, welcome to my talk on the Agile movement. I'm Russell Sherwood and I'll be joined later by my colleague David Sale, who will be joining me for a demo. Now I'm going to give you an introduction to the Agile software development methodology. And this is aimed at anybody who perhaps works in a waterfall software development environment, or perhaps you don't have a specific methodology in mind, and anybody who's curious about Agile and how it could benefit your development team. And if you're skeptical today, here's 3 reasons why Agile might help you. Firstly, Agile can bring you better quality software. If you're wondering why, you'll see by the end of this slideshow. Also, it'll bring you happier clients, and I'll introduce exactly why in a minute. And thirdly, if I think back a few years before I joined my current company, Sky, when I worked in a waterfall development team, I remember when coming very close to the end of a project deadline, working a lot of overtime. I remember one specific night working until midnight at work, then going home and continuing working at home throughout the night on this project. And the thing is, this is very common within a waterfall development team. In fact, just by show of hands, has anybody worked similar kind of overtime in the last month or on the last project?
Last 2 months, yeah.
Yeah? A few of you? Well, let me introduce to you why Agile can reduce the overtime that you will do. So there's 3 things why Agile will be useful to you. Quality software, happier clients, and happier developers. Today we're going to cover a brief comparison against Waterfall and Agile. I'm going to show you the Agile life cycle. I'm going to show you what a typical Agile team looks like. And I'm also going to show you a typical Agile month and some meetings and events which are typical in an Agile life cycle. This talk is about 45 minutes, and then there'll be a 10-minute gap for question and answers. So if you could keep your questions till the end, but if anything's unclear, please do feel free to raise a hand and interrupt. So as I've already introduced, I'm Russell Sherwood, and my colleague David Sale will be joining me later. And we're from British Sky Broadcasting, which is a company based in southwest London, and we provide satellite TV, broadband, and phone products to over 11 million customers. We also have a range of web applications to back up this content. And we have TV over IP services as well for our customers. So this provides them with streaming live television through their mobile phone and also on the internet. And deliver all of these things, for example, we need this box software for the set-top boxes, we need the websites to deliver our products, and we also need these applications and everything in between. We need a wide range of development teams, and we're coding in Java, Ruby, and of course Python, just to name a few. And there's one thing in common to every one of these development teams. They all use Agile. And Agile is very useful at Sky. It's very important to us because we work in a very competitive marketplace. And what Agile allows us to be is we can be reactive to anything that our competitors do. So the great thing about Agile is it allows us to release frequently and respond to any changes often. And that's why it's very useful to us at Sky. Now specifically, David and I work on a team called Product and Offer Management. And this is a system that sits within Sky's sales platform, and it provides a service which provides complex information about the products and offers within Sky's product catalogue. Agile is very important to us because we store all the offers that Sky has, and we need to respond constantly to any offers that competitors may have. So again, we need that constant feedback cycle. We need to be able to react to the marketplace and respond to that. So first, let me introduce you to some comparisons between Waterfall and Agile. So let's imagine that this pixelated blue triangle is the Waterfall methodology. At the top there, we have our fixed aspects of Waterfall, and that's the requirements. We know that we need to deliver requirement A, B, and C. At the bottom there, what's estimated is the time that will take and the resources it will take. This is why, when we're coming to the end of the project, towards the deadline, we find ourselves rushing because we've underestimated the time it will take to deliver these requirements. Now, if we switch around that triangle, we have more of an idea of what the Agile methodology looks like. So here we have the fixed aspects of the time and the resources that we're going to dedicate to this project. Let me explain there is that we're going to separate the time that we have for our project into small chunks which we call sprints. Typically in our team at Sky, these sprints are 2 weeks long. And so we estimate then what requirements we're going to deliver in each 2-week sprint. Let's look at that a slightly different way. In these graphs, the blue blocks represent the features that we deliver to our clients, and the horizontal axis represents time. So here in a typical waterfall project, some of you may be familiar, a lot of time passes, and then all of a sudden we release our product, and it's only at that point that the client sees it. And that's why with the red line you see the risk of failure. The risk of failure is always increasing because the client hasn't seen any product right until the last moment. If we switch to Agile, we see that at the end of every 2-week sprint, we actually have a working release of our product, and we can release that to our client. This severely minimizes our risk of failure. So you can see that every single sprint, the risk is reducing. This is because we've introduced a constant feedback cycle. Our clients see the product, and we can then react to their feedback, thus reducing the risk. Looking back now to the waterfall methodology. Some of you may be familiar with this. So, in a typical waterfall project, you're going to first start on the analysis. This is where we gather our requirements. Let's say this will take perhaps 1 month. Then only once we've got our requirements, we can start on the design. We start designing our system, perhaps wireframes. Let's estimate this another month. Then our development can begin, only once we've got our requirements and our design. Let's say development takes 2 months, and then we've got a month of testing. Problem here is that now 5 months down the line, this is when our client receives our product. And then we've got a constant maintenance cycle. But that's 5 months of time has gone past in this project. So perhaps what the client wishes have changed, perhaps they may at that point realize that what they wanted is different to what the development team understood that the client wanted, and then we've got problems. The Agile lifecycle can fix this problem, and this is what the Agile lifecycle will look like. The entire project will be broken down into tasks known as story cards, and this forms what is known as the product backlog. Each of these red blocks represents a story card. Now, remember I mentioned a sprint. Now we're going to take a subset of those story cards, and that's going to form a sprint backlog. Now what a sprint backlog is what we estimate we can deliver within this sprint, typically perhaps 2 weeks. Now every single one of those story cards will go through this story card lifecycle. It will start with a defuzz, where the development team will discuss with other members of the team and nail down the exact requirements for this task. The development team, along with the quality assessment team, will then write tests together and then write the code to pass these tests. Then only when the card passes specific criteria, called acceptance criteria, we then say that this card is done. And this card is then ready to be released at the end of the sprint. Now there are many flavors of Agile, and you may indeed have heard of some of these. I'm just going to discuss today what the key things are and how things work where I work. But the most common Agile flavor is Scrum, and that's used in approximately 50% of Agile teams. At Sky we use predominantly Scrum, and we use some extreme programming or XP practices as well. However, there's a few things that these all have in common. And in 2001, 17 developers met at a ski resort in Utah to discuss the future of Agile. And they came up with something called the Agile Manifesto. And they said, we favor individuals and interactions over processes and tools. That is, they recognize that self-organization, self-motivation, and co-location of teams is much more important than the processes of a project. They also identified that we value working software over comprehensive documentation. It's much more important to get quality working software than to make sure that we've got all the documentation done. That's not to say we don't need the documentation, but we're identifying here what's more important. We'd rather spend our time making sure we've got quality software than writing documentation to cover every aspect of it. We also value customer collaboration over contract negotiation. So in a waterfall project, you may notice that there's a lot of upfront contract negotiation with the client. You're nailing down those requirements during the analysis phase. With Agile, there's constant customer collaboration. This is very important for the feedback loop. We're always releasing and we're getting our client or our stakeholders' feedback on that, and we can change our product and make it better and more in tune with their exact requirements as a result. And finally, responsiveness to change over following a plan. Similarly, we've got the feedback loop, and we get the feedback from the client, and we can respond to any changes that they have in requirements. And as I mentioned earlier, there is value on the things, on the red items, the items on the right, but we value the items on the left more. So you can't just say, oh, we're not going to do the documentation, that's Agile. Documentation is still important, but working software is more important. Now I'm going to introduce you to what a typical Agile team looks like. So the ideal Agile team is between 5 and 9 co-located members. It's much better that all the members of a team are in the same place, so we maintain the communication throughout the team. This is very important in an Agile team. And if at all possible, this should be done. And this is what our team looks like at Sky. So we have the Scrum Master. Scrum Master's role is to facilitate the team. They'll be ensuring that all the Agile processes are followed. They'll be making sure that specific events happen at the right time. They'll be making sure that everybody that should attend are there. Their role is also to remove any impediments that the team may have. So, for example, if the development team have any problems in delivering the story cards that they're tasked to do, it's the Scrum Master's role to remove them. They'll also act as a buffer between the team and the stakeholder. This is very important because it prevents overcommitment and any distractions of the development team so they can focus on the task in hand. What's very important to note is that there are some distinctions between a typical project management role and a Scrum Master, in that an Agile team is self-empowered. So all of the teams have empowerment. And a typical project manager role from a waterfall team could fit into many different roles in an Agile team. So perhaps they could be a Scrum Master, they could be an analyst, or they could be a manager of several teams. It all depends on the company, the size of the company, and what the company does. Next on to the analyst. The analyst is the owner of the product backlog. They'll be managing the cards, and they'll be the ones deciding the priority of the cards that are going to be delivered in each sprint. They are the bridge between the stakeholder and the development team. So to the development team, they are the voice of the stakeholder. And it will be the analyst that will be going to the stakeholder and nailing down exactly what's required for each card. And we also have a quality assurance team. The quality assurance team will collaborate constantly with the developers to ensure that we have tests in place and edge cases for every single card. They'll also be the last point of call for every single story card to ensure that the card meets the acceptance criteria specified. And only when the QA team are happy that the acceptance criteria are met, then we say that this card is done. And that's when the card is released in the product that's released at the end of the sprint. So let me introduce you to the typical Agile life cycle. Central to the team will be the Scrum board. Now this is like a whiteboard or a pin board, and this will be the key point of communication between the team. Using this, the whole team will be able to see the status of the project, and they'll be able to see what all the members are working on at any particular time. Now you'll notice here that we've got the story cards in post-it note form, and at the beginning they'll start in the first column on the left in the product backlog. And as cards are done, they'll move their way to the right. So first, once we have decided what card's going to be in the sprint backlog, the cards that will be in the sprint backlog will be moved to that column. Here it's marked to do. Then, when a developer is free, they'll pick up a card and move it into the work in play column. At that point, you'll see that we've got these little Simpson characters. These are avatars, and each one represents a different developer. When a developer picks up a card, they'll put their avatar on a card so that the entire team will know who's working on what at any particular time. When a card is done, it will then be moved to the testing column. This is when the QA will ensure that the cards meet the acceptance criteria. When the QA team are happy, then the card moves to done. You'll notice here that we've got three different colours of post-it note. And this is a suggestion, and this is the way that we work on our team. So this indicates the different types of story card that we may have. We could have a regular story card, here shown in blue. We could have defects, shown in pink. It's important to distinguish between these because we really want to get these released as quick as possible. And also there's technical debt. Now there are many online Scrum boards available if it's not possible to have an actual Scrum board in your team. So this is one that I like. This is Trello, but there's many available, so try them out for yourself. But these are available in case it's not possible to have a whiteboard in your team. Now, every working day starts with a daily stand-up. Now this is an opportunity for every member of the team to answer 3 questions. They'll say what they did yesterday, what they're going to do today, and any impediments that they may have to do their work. Remember that it's the Scrum Master's job to remove these impediments from the team. Each member will talk in turn, and to manage this, you can have a little token, perhaps a ball, that passes around between the Scrum during the stand-up. This ensures that just one person talks at the time so that other people aren't interrupting. This is very important because this is an important collaborative feedback event so the whole team communicates what they've been doing. Also, you'll notice that everybody's standing up for this meeting. This is because it should typically be no longer than 15 minutes. And in everybody standing up, this encourages this to happen. Now, let me introduce you to a typical Agile month. Okay, so this month is split into two sprints, two weekly sprints. Every sprint begins with a planning game. This is where we plan which cards are going to be delivered in this sprint, just an estimation. And then at the end of every sprint, we'll end with a showcase, a release of the product, and a retrospective. And I'm going to explain what happens in each of these events now. So at the beginning of every sprint, we have a planning game. This is where the analyst will present every story card in turn, and each member of the team will have a set of planning poker cards, similar to what we have here. Now you'll notice that there are abstract numbers in the Fibonacci sequence here. This is going to be representative of the effort that the developers think will be required for this particular card. And there are different scales that you could use. For example, some teams use t-shirt sizes, small, medium and large. It all has the same effect. The idea is it's an abstract scale. And you also get more of a feel as you progress through sprints on the relative size of each card and what each card means in terms of size. Now, each member of the team will then present a card on the count of 3, and then an argument ensues, or actually a peaceful discussion. Firstly, the people at the lower and higher end of the scale will contribute their ideas on why they think it's those particular numbers. And then the entire team will have a revote. And this will continue until everybody agrees on the effort required for that card. Now these numbers are quite important in that as we progress through several sprints, you get an idea of how many points you can deliver in each sprint. And this is known as velocity. This can give you a lot greater ability to estimate as you progress through your project. And this is our typical team at Sky. This is us for taking it in a planning game. Don't know if that's clear at the back, but you can see that each team has a set of cards, and also these planning poker cards are available as an app, as some people are using there. Right, so what's it like to develop within an Agile team? So we've got our cards for this sprint, we've had our planning game, development begins. And every single card starts with a defuzz. This is where the development team, the people who have decided to do this story card, will sit down with the QAs, the quality assessors, and also with the analyst to discuss exactly what's required for this story card. Remember that the analyst is the voice of the stakeholder, so they'll be able to answer any questions that the developers may have. This is the point of the defuzz, so the developers are exactly clear in their mind what's required to deliver this task. Within our team at Sky, test-driven development is very important, and we use it for every single card that we do. For those of you unfamiliar, this is where we write a failing test first for the code that we're about to do, and we watch it fail. We then write the code to pass this test, and then run the test again, and once that's passed, we know that our card is done. This is fantastic because it keeps our focus. We're just coding for the task in hand. It prevents any gold plating. Imagine if we're doing a login form and then you suddenly think, oh, wouldn't it be great to have this pop-up window or some bells and whistles on the form? But test-driven development prevents this happening because you're always coding just to pass the tests for this card. We'll give you a little demo later of what it's like to work in a test-driven development environment. Now also, in our team at Sky, we use pair programming. Now this is a practice that's commonly used in the flavour of Agile called extreme programming. So some Agile teams may use it and others may not. We find that it really works at Sky. It really helped me when I joined the team because I was entirely new to Python when I started at Sky. And in pairing with senior developers, I learned a lot and very quickly from them. And it wasn't just a one-way process because they learned new ideas, new processes and new coding styles from me at the same time. There are other advantages to pair programming. It brings confidence in the code that you're writing. It's much better to have two heads looking at your code and you know that somebody else is reviewing your code as you code. You also have the shared success. This really boosts team morale. When a card is done successfully, you can share that success between your pair. You can learn and share coding styles, and also pair programming leads to better designs, shorter code, and faster problem solving. And more importantly, mistakes are caught early. So because you've got two heads looking at the same piece of code, you'll have fewer defects in your software and better quality software. So I've explained test-driven development, and for unit testing we use nose and unit test Python packages. We'll show you what that's like later during our demo. We also use behavior-driven development. Now, for those of you that may not have worked using behavior-driven development, this is where we write tests in the form of given a user goes to a login form, when they type username and password, then the user will be logged in. So we have that given, when, then syntax, which is known as Gherkin syntax. And for those of you who are interested in learning about behavior-driven development, we had a talk last year at EuroPython 2012 entitled BDD Testing in Agile Development at BSkyB. And that's available on YouTube or the EuroPython website if any of you are interested in BDD and looking into that further. We also use deployment scripting. So for this we use the Python package Paver. This is useful because every member of the team, whenever they check in to the code base, there's a suite of tests that are run. This works as regression testing, so every time we release a new piece of code, we've got a whole code test suite that's running, so we know we haven't broken any old code. This leads to reliability and quality in our software. Now finally, if we look to the end of a typical sprint, we have the showcase. The showcase is like a demo of the software, what you're going to be releasing in this particular sprint. Here, if you can see them, they're a bit dark images, sorry about that, but you can see that the team is watching a working demo of the software at a showcase. At a showcase, it's meant to be an open environment, so the team may be invited, but also other teams perhaps, maybe the stakeholder may be there, anybody that's involved or interested in the product and what you're going to be releasing. And you'll be demoing exactly the features that you're delivering in this sprint. Also at the end of every sprint, we have a retrospective. A retrospective is a key feedback point for the entire development team. In fact, for the entire Agile team. And this is where the whole team will get into a room and they'll have a set of post-it notes. And each team will contribute their thoughts on how the last sprint went. And they will discuss what went wrong, they'll discuss what went right, and they'll discuss things that they can improve for the next sprint. This is very important for our feedback cycle. So remember, as well as we've got the feedback from our client, here we get the feedback from our fellow team members. A suggested way that you could run this retrospective is you could have different colour post-it notes. So here for the what went wrong, we've got the pink ones, what we could improve, yellow, what went right, green. And then each member of the team will discuss, in turn, each of the different post-it notes. And using this, we should come out of a retrospective with action points on how we can improve in the next sprint. So it's a constant learning process, and we're improving as we continue through the different sprints. Now, I'd like to invite my colleague David Sale up, and we'll go through a demo. So today, we're going to show you the typical life of an Agile card in the Agile life cycle. Sure. Sorry, bear with us.
The mirroring thing's not in the top.
Oh yeah, go to show all.
Pair programming.
Yeah.
Yes.
Show mirroring.
Op arrangement.
Ah, yeah, there we go. No worries.
Okay, so today we're going to show you the life of an Agile card through the Agile life. Oh, sorry. Through the Agile life cycle. Oh. Is that okay? Through the Agile life cycle. We're also going to demo what it's like to work in a test-driven development way. Can everybody see the screen okay from where I'm standing? Right. Okay, so we've got two available developers. We're going to take a look at the sprint backlog. Notice we're using Trello here that I introduced earlier, an online Scrum board. So let's take a look at the sprint backlog, and we're going to pick up this login form. Let's open that. Sorry, do bear with us, typical teething problems. Okay, perfect. Oh yes, number of times we've gone through the demo, but we knew this would happen. Perfect, okay, so if we pick up the card, we want to look at that acceptance criteria. Remember they're in the given, when, then syntax. So here we have, given the user is on the login page, when the user enters their email and password and clicks the submit button, then the user should see the OK message. So that's our acceptance criteria, and we know once this passes, then this story card will pass. Now, because this card is in the sprint backlog, we know that we've had a planning game, and this card has been given 8 points. Okay, so
Hello, testing. I'll leave me this one.
Okay.
What's going on? Yeah. Oh, this one.
thank you. Hello. Right. So we're going to be using Selenium, which is a great unit testing package for testing user interfaces. So here we have setup method, which will be run before every single test, and this will create a WebDriver instance in Chrome. We also have a tear down method, which will be run after every single test, which will destroy that instance. And we've got one test user can log in, which at the moment goes to this URI and gets the source code. We also have a Flask skeleton. All this is doing is rendering the template from login form HTML. And at the moment, if we take a look at that URI, we'll see we've got a blank canvas ready for our login form. Right, so as we're working in a test-driven development environment, we want to write the test first. Now you'll remember that from our acceptance criteria, we want to add an email address. And in Selenium, we check this using self.driver.findElementById, and then the ID of the element we're looking for. So let's run this test. Remember, the code doesn't exist yet, and we want this to fail. This should be a failing test. Indeed, it has failed, and we get a very useful error message which tells us exactly what's happened. The element doesn't exist. We get a no such element exception, and also we're told what test this failed on. So we know exactly what code to write in order to pass our test. So let's write this element. First, we're going to give an email, a label for the email address field.
Why is that of course? It's not in your test.
Sorry, what was that?
Why is that of course? It's not in your test.
That's a very good point. Sorry, the gentleman at the back said, why is that of course? Indeed, we didn't write a test for this label, and if we had more time, we would. It's just for the sake of this test so that we can fit it in within the time allowed. But you're certainly right. If we were coding completely test-driven development, we would be writing a test for this label. Thank you very much for noticing that. Okay, so we've written our input field, and so let's run our tests again. Okay, and that test has now passed. Let's take a look at that. Okay, great. So we've got our email address field. Now you remember also from the acceptance criteria, we wanted a password field. So let's write that. Using the same way, we're using an assert statement to check that the element exists and checking find element by ID password. Using Selenium, you can also find elements by class or name as well. So let's run that test, and we see indeed that that element doesn't exist. And we're given a very useful error message to show us exactly why the test has failed. So let's add that. We're adding the label there, which of course we'd have a test for in a proper environment. And we're going to add the input field, ID of password, and a type of password. Let's take a look at what that looks like. Right, our tests have passed. And let's take a look. Now you'll notice there wasn't actually a test to test the attribute type on that input field. So let's do that for the submit button. So in a similar way, the find element by ID can return an object which represents the element. And on that element, we... Oh. Carry on. Sorry, I was ahead of myself. So on that object, we have the getAttribute method that we can run to check the attributes on that object. So we're going to check type, and we're going to check that that is equal to submit. We run that test, and it's failed for exactly the same reason. The element doesn't exist yet. So let's quickly add a submit button, ID of submit, and a type. Let's test this. Let's put text, and let's see what happens with the test. As you'd expect, that's failed, and we've got a very useful error message on why that's failed. So we've got an assertion error, text is not equal to submit. So we know exactly what to code. We know we want to change that type to submit. Let's try that test again. And we've passed. Let's take a look at our form. Great. Now given more time, of course, we'd style this. We'd add some CSS, make this look a bit nicer. We've done that already, so it would look like this. And of course, we'd have some background code to actually authenticate the user and log them in. But it should indeed still work. Yeah, let's run that test. Oh, well, there's something we didn't try before. Let's not worry about that. That wasn't planned, but thank you very much for for that. I'm sure there's a very good reason. Ah, there we go. The IDs are slightly different. Right. So let's imagine that we've added that background test. All the tests, the background code, all the tests are passing. We can then move the card into QA. So at this point, the QA team can then pick up the card and double check that our code matches the acceptance criteria. Once they're happy, they'll move the card into the done column. And as available developers, we'll go back to the sprint backlog and take a look at what cards are available. And we start working on the shop widget. Yes, hello.
As I saw in teardown you had a closing driver for Chrome, but it looks like that you still have a lot of Chrome instances while repeating your test.
You're absolutely right, yes. For the benefit of anyone that didn't hear, we did have a teardown method which was intended to destroy the Chrome instance after every single test. Now, this worked on David's computer and it didn't on mine, and we never actually really looked why that happened, but it certainly should destroy the instance, and thank you for noticing that. That's absolutely correct. Never did work out why, but I'm sure it's a very simple reason.
You should look now.
Okay.
For the questions, probably. Oh.
Certainly sounds like it's working. Sorry about this, everyone. Hello. I invite you all to become more agile today. So, just to summarize, and then adopt an agile life cycle. This will allow you to release often, receive frequent feedback, and react to feedback quickly and efficiently, which will lead to quality software, happier clients, and a happier development team. Thank you. Any questions?
Yeah, suppose you are dealing with a classical prima donna developers that is the only one able to maintain your code, that by the way, you don't document it very well because you are following your agile method. And this guy doesn't give a damn to come to your quarter of an hour meeting in the morning. He's coming at 11 and leaving at 12. He's doing a perfect, fantastic software. What you do? You make him redundant or you keep him?
Well, it's the Scrum Master's role to ensure that everybody attends the meetings as they should. So they will ensure that everybody attends at the right time. Now, I've seen different ways of ensuring that everybody appears at the daily stand-up. One, and I worked on this team at some point last year, was that if anybody's late, they have to put £1 into a pot, and that pound is then collected, and at the end of the sprint, the team is treated to lunch based on thanks to all the people that were late. So quickly, you ensure that developers aren't late for the stand-up, and if they are, hey, we all get free lunch. Does that answer your question?
Yeah, psychological things are more complex. But anyway, another question. Suppose your customer base is such that you cannot simply align all of them at the same time to the same release, but maybe they have their software filled in some, I don't know, E-square, EEPROM things, so that you get your customer support people receiving phone call from hundreds of people having dozens of different releases of your software that are not aligned, and then you get crazy understanding which release this guy has at that time and which bugs is in that release. So it's not that always so easy, like, I don't know, in your case maybe easier, suppose you are upgrading a certain web server and then people always download these things. But when releases are more complex to deal with, I mean, your method cannot always work.
So what you're saying is that, just to make sure I've got your question correct, you're saying what happens when you've got different sets of customers and you want to release one version of software to one set and another version to another. Is that?
I'm saying that you cannot always pretend that people get up to date to your latest releases, and if you are, again, sometimes you are forced to have specific releases at a certain time just because you simply have a certain hardware coming out at a certain time, and you have to be there at that time, and you have to to provide the next release in 6 months from now, just because the next hardware will be available at that time. That's something that happens. You have to deal with that. That your releases time are fixed and constrained by something else, not just by your development. And you cannot simply say, every 2 weeks I provide software to my customer base, because your customer base will not receive it.
Okay, this is true. Perhaps at the end of the sprint, you might not always have a releasable version of your product. In this case, you may release it just internally or to other teams so they can test. You don't always have to release your product at the end of every sprint. So it's not always essential.
Yeah, but in this case, you will be missing the feedback from the customer base then, okay? This is something that makes things more difficult.
Okay.
Can I just pick up on the first point that this gentleman raised about people not turning up to Scrum? You're quite right. It's the Scrum Master's responsibility to make sure everybody is there. And in our teams, we've adopted a process where we will start the Scrum even if some people are still walking there to try and encourage everyone to be on time. We have one guy in our team who, for personal reasons, works in a mid-Atlantic time zone. And so because the team is empowered, we decided that the best time to have our scrums was at 11:45, just before lunch. That has two effects. First of all, it means that this guy who wakes up late can make the scrums, and secondly, it gives us a second reinforcement for when the scrum will end, because everybody has to go to lunch, usually the pub. So you don't want your scrum to be too long.
That's fantastic. Thanks for your contribution. So, of course, depending on specific reasons or your specific team, you may change certain processes. So you could put your daily stand-up back, put it later to accompany different time zones. Sounds like a great solution. Thank you. Hello.
Hello. You were comparing the waterfall method to the agile method. In the waterfall method, the first two steps were analysis and design.
Can you put the microphone?
Sorry. Yep, the first two methods in waterfall were analysis and design. That corresponds to the job of the analyst in the Scrum. Is that correct?
Yes. So the analyst in a Scrum team, in an Agile team, will be focused on gathering the requirements from the stakeholder. So it's very similar to the analysis process.
And you mentioned in the waterfall method it took quite a long time to do the analysis and the design, typically maybe a month or something you were saying. Is there much lead time in this method in Agile? Does the analyst have to work on the thing a month before you even start?
Well, you see, the difference is that in the waterfall methodology, you'll get all the requirements up front for the entire project. While in an Agile team, the analyst will just get the requirements for the requirements at that specific time. So they just want to get the requirements, for example, for what's going to be delivered in the next sprint, and it will be an ongoing cycle. So you'll continually get new requirements from your client. Does that answer your question? Thank you.
Can you hear me? Yeah. I just wanted to make a comment maybe about what first gentleman said. That sometimes you do have external constraints which don't let you actually kind of do it textbook Agile. But contrary to what Agile Manifesto says, you actually can use parts of Agile and they work by themselves, just parts. And you can still do things partially Agile to get the benefits of those parts that you're using. For example, I work for the UN, which is like not the most Agile organization, as you'd imagine. And for example, the test team is a separate team for basically structural reasons. They are separate from us, but we are still doing test-driven development. So unit tests are kind of done in an Agile way, but then the functional testing is done later, just because that's how things work. And we sometimes give the customers something like a waterfall-like interface on top of actually Agile process. So they have to pay for it a little bit, but it works better in the end and it's more predictable. So really you can still combine things and kind of figure out your own way which will work for you, I think.
This is fantastic. Thanks for your contribution. So indeed, every company is different and every team is different, so you can adopt Agile and take the processes that work for you. Thank you.
Okay, another question here. I also actually work for the UN in Rome, Food and Agriculture Organization, and I'm trying to get, as the gentleman just said, some agile methods into the bureaucracy there, but it's a big mess, and I was wondering if you have if in Sky, when you arrived there, they were already using agile, or was it something that started afterwards, and if so, any tips on helping teams that are not used to it get basically the bosses to agree to give it a shot?
Thank you for your question. Yes, so when I started in my team, the team had already adopted Agile. However, in order to integrate me, I went on a week's training course to ensure that I was on board and I agreed with the Agile methodology. So that's perhaps one way, perhaps ensure all staff are fully trained and that they're all on board and they buy into the idea of Agile. Perhaps show them why it's going to be a great idea for your development team. And that's what I'd suggest, is to make sure that you have the training in place and make sure that you have buy-in from all members. Does that help? Thank you. Yes?
So you compared Agile to Waterfall and stressed the iterative development cycle of that. I came, as it were, of age in my programming career in the 1990s with, like, say, Steve McConnell's Rapid Development book, which stressed the, the Rapid Application Development methodology, which also stressed iterative development it was known back in the 70s. So many of the things you've talked about seem to be the same thing that were in rapid development, the books I learned in the 1990s. So what are the differences, not between Agile and Waterfall, but between Agile and rapid applications development methodologies? Most of the things I see, like daily builds, has a heartbeat, being able to deploy, iterative cycles, all seem to be part of that same sort of thing. So what are the differences?
Thank you for your question. I haven't personally worked in a team that uses rapid application development. However, it sounds that this perhaps was a very early version of lightweight software development. And you remember that in 2001, a group of developers came together and they gathered their thoughts on the future of Agile. So indeed, perhaps this methodology may have contributed to the future of Agile. But I'm sorry, I can't...
It's only did, but I don't know the differences are. When people talk about Agile, I can't tell the difference.
Between RAD and Agile? RAD. I'm very sorry, I can't answer that for you right now, but if you feel free to email me, I will find out and I'll get back to you.
It seems that everyone talks... It just seems that when everyone talks about Agile, they compare it to Waterfall, but there are any number of best things that were in the 1990s labeled best practices. That seems to be the reference should be not between Agile and Waterfall, but between Agile and best practices of 10 years ago to know what's improved.
Indeed, thank you. Well, my aim for this talk was just to compare against Waterfall because a lot of people are familiar with Waterfall. But indeed, that's a very good point. Thank you. Hello.
Hi, thanks for the excellent talk. I'm wondering how using agile methods would help me with the following situation. I have a client with a project, and by its nature the project is hard to loosely couple. It's a very complex architecture. Yet, so we have a basic design because we start up quickly, and halfway through the project it's going on very well, and suddenly it turns out that there's a design choice that was misunderstanding between you and the client, but it affects a lot of elements in your design. So it would take a lot of time to refactor to meet the new demand. Is that just a thing that Agile can, by its nature, help with, or is it a different problem?
So you're saying you're experiencing that you're developing and then your requirements are changing halfway through?
Right, like an assumption was made that turned out like, oh no, that's not what I wanted at all, said the client. I wanted X, and you should have known that, but you started writing things too fast. You should have designed we should have sat down longer at first to get a better understanding of what the requirements were.
So Agile really lends itself to this scenario because we're releasing a version of our product often, and your stakeholder, your client, will get to see the product early. You'll then get the feedback early from the client, and you'll be able to react to that. And then you'll be able to bring any changes that they suggest, perhaps into a later sprint. So really, Agile helps. It would be so much easier in an Agile team. Does that answer your question?
I hope it will help. Yeah, sounds
Well,
good.
certainly give it a try, and good luck.
Sure.
Hi.
Hello.
I want to ask you if you use a bug tracker, and if you do, how does it interact with Scrum? Because it seems to me that there's like some overlapping. For example, if you have a bug tracker, you can have an issue, and it can be in progress, it can be done, or it can be like a to-do. So do you use a bug tracker? How does it interact with this?
No, we don't use a bug tracker as such in our team. We use Jira to keep track of all of our story cards, and any defects will go into Jira just as another story card. So no, we don't on our team. Okay.
Sorry, but the time is over, and we have another talk, so I cannot delay. But I want to recall everyone about the pie barbecue this evening, and in 5 minutes or so, the next talk will begin. And so, thank you.
Great, thank you. Agile.
Maybe a silly question, but
sure.
How does it work when, in fact, you can't do the analyst told the developers to...
Oh, sorry.
Okay. But
I'll just pack up. I'll meet you outside, okay?
Anyway, can talk.
Yeah. Allora.
I'll ask you to just outside, okay? I'll be there in just a couple of minutes.
Allora.
Do I have everything?
Si vede un tubo.
Yes. Well, yeah. Just wait.
Thank you.
This is yours, one drink?
Oh, no, I'm okay.
Okay,
Devi settarlo così a basso livello?
Sì, non lo so, io lo faccio così. Abbiamo 4 minuti. Allora, era questo, no, questo, detect displays. Configure.
Yeah. Maybe it's better to shut up. L'hai acceso e smutato? No, guarda.
Hello, hello. Can you hear me?
Tagliatelle, siamo finalmente pronti con la prova audio.
We can make it.
Microfono, prova microfono del...
We have some technical problems, sorry for that.
Allora, adesso sto provando il gelato. Ho appena provato il gelato. Guarda che succede? Il clip che... Ora si è rotta la molletta tagliatelle un attimo.
Can you hear me? Okay, so we have some technical problem because if I put it full screen, it will show here. So we are going to show it like this. I hope that is not going to be a problem. Okay, so I guess we can start?
Yeah, start.
Okay, so I'm Ezio Melotti, he's Franco Carbognani, and we are two members of the Italian Mars Society, and we are going to present this talk called Python on Mars. Do you have the microphone? Okay. Okay.
Yeah.
Particular quote.
So thanks for coming, and yeah, as said, we belong to the Italian Mars Society. That is a chapter of the Mars Society advocacy organization that is worldwide. So let's start with some prediction from the previous centuries. These are predictions from the 19th century. As you can see, I don't know, they were talking about rail travel and quite interesting prediction. Same kind of prediction for the 20th century. For what concerns aviation, you see, they speak by themselves. And also some 21st prediction. I don't know, in 2006, estimation that traveling to Mars would be, again, putting your brain in big danger, or a statement like that is virtually impossible. So in my opinion, as you can definitely laugh about the prediction we saw before from previous century, in my opinion, in 100 years from now, there will be a place like this one in which people will be laughing on prediction that has been done, that are done at the beginning of this century. So instead of just, again, making those kind of useless prediction, I think it's useful to look at the reality, to look at a real problem, having, let's say, an engineering approach to what are the so-called Mars showstoppers, so that are the threat on human health and safety that can really make a mission to Mars impossible. So these are the so-called 5 showstoppers: hypogravity, radiation, and obviously need for regenerative and bioregenerative life support. I mean, to make you living during the travel and on Mars itself. Also, Mars dust. It's definitely a problem that need to be managed. And last, you need to assure that you are not creating problem while you are going to Mars, especially because you want to study if life is already there, and also, I mean, don't get contaminated with whatever is there on Mars, if possibly some life is there. So.
Okay. So yeah, I can tell you something more a bit. So hypogravity, as you might know, like Mars is more or less half of the size of Earth, so it's quite small. The gravity is also smaller. We have like 30% more or less of gravity in here. So hypogravity, it might cause problems because if we have a mission on Mars, people will stay there with a different gravity that we have on Earth. So we are not adapted, their muscles will suffer this, and we are not evolved to live with this kind of gravity. So this is the first problem. Then we also have radiation. This is something that will affect both the travel to Mars and also the life on Mars, because the atmosphere on Mars is like thinner than on Earth. It won't protect you from all the radiation that you get from the sun. So if you go and live on Mars, you need to protect yourself from the radiation. Then like I guess all of you like to breathe, eat and drink, and if you go to Mars you probably want to continue do this, and to do that you need to figure out something. So you need some way to get the air, the food and something to drink, and you can do this by recycling as much as you can, but also like by producing things. You can have greenhouses and grow some vegetables. And the other problem is Mars dust. This is an actual image from the Opportunity, and it shows like a Mars dust storm. And dust on Mars is actually a problem because it might affect both the machinery So the dust can get in, especially into mechanical parts. It can consume all the machineries. And also it might be dangerous for humans, because there are like fine dust that if you breathe this dust, if it gets inside the habitat, inside the station, you might breathe it and it might be dangerous for you. And as he was saying, like the planetary protection, both ways, because you don't want to bring anything there and you don't want to bring anything back. If you saw this movie, the plot was something like some alien forms get on Earth and then starts killing everybody. That's probably not likely, but you get the idea. Okay, so.
Yeah, obviously to study the problem, so those showstopper, you need some way to do it, and the best way to do it are analogs. So you would like to have analogs of the same Martian condition you will find here on Earth that allow you to study the problem and to find technical solutions for those problems. So there are already many, let's say, analog stations here on Earth, but they have some limitation. They tend to stay on extreme environment, and in this way trying to simulate as much as possible the condition you will find on Mars. But there are obviously limitations on that. So for example, for what concerns shielding, normally you have this station that are like classical tuna can, and till now, I mean, not big effort has been made in shielding, also because again, shielding those tuna can is not always easy. Sealing is again something that is not yet done very well. Those structures are normally not sealed, and in this way try to simulate a complete closed life cycle become difficult, and again not talking about dust control that at this point become practically impossible. For what concerns the location, at the end of the story, I mean, supporting those stations in extreme environment become in itself such a problem that typically they tend to not to do simulation implying very advanced technology, because at the end this becomes too difficult to be supported and maintained remotely. They can use for very short times, typically during, I mean, the best, let's say, the best season. And also they become at this point very expensive per man hour. And they, okay, in many cases the logistic cost become the measure cost to run them.
Yeah, and as an example, I was staying at this station here for 2 weeks, and you see, yeah, the Mars Desert Research Station in Utah, and you can see how well it's sealed. We got like mice coming in, and I was feeding them, taking picture of them. So this shows that it's not just like keeping dust out, but even like mice were coming in, so it's not really sealed that well.
At this point, also after the experience I had myself at MDRS in Utah, here within the Italian Mars Society, we started to come out with the idea of having something alternative to this, let's say, remote place station. So we started to study in which way you could overcome some of the limitation of the existing station. One of we came out with this idea of the European Mars station, in which we would really focus on the points that are now not very well studied in the existing station. So for example, for habitat shielding, we would like to have a station in which the new ideas like this membrane water wall concept will be used. Basically the idea is that the habitat will be an inflatable habitat, and then you can add those membranes on top of it, and those membranes can provide you many things at the same time. They can provide you shielding against radiation, that will be basically the water and polymer, and at the same time you can also grow things like spirulina algae inside the water that is inside. So basically these things will provide you both radiation shielding and be part of the bioregenerative system of your station. The other innovation are for what concerns the sealing. The idea is really having this station completely sealed so that all the technology that are needed, for example, airlocks, will be very well studied against the dust, for example. And also for the location, I mean, if you put the station somewhere, I don't know, in Milan or near Florence, at this point logistical costs are very limited. The facility could be used all the time, and they can be supported by an engineering crew, I mean, nearby. And also advanced technology like photovoltaic power generation can be studied. And at this point, the basic idea is that the habitat would be placed inside, for example, a big hangar, and inside this big hangar, for example, you can simulate a Martian dust storm. Just to tell you, there is an institute, a research institute in Denmark. They are producing the equivalent of a Martian dust. So they know the chemical composition and they can produce dust for you. The idea is that you can take this dust, you put it into an hangar, and you create an artificial Martian dust storm, and you study the way your habitat is really behaving in such conditions. In extreme environment like northern Canada or Antarctica, you cannot do this, or you could do it, but it would make very little sense. Instead, you could do it in the yard of your home by using a simple hangar in which you can replicate some of the conditions you would have on Mars. Then, okay, you can go. Next point.
Non abbiamo molto tempo, vai spedito.
Go.
No?
So, yeah. For what concerns the typology, we are thinking of using an inflatable structure instead of, let's say, hard shell module. And the main advantage is that you would have a larger volume, lower mass, and in this way your crew productivity would be enhanced. And also, quite surprising, I mean, your habitat would be even more reliable and easy to repair instead of hard shell. And this is, I mean, the first early design that we are doing, in which these modules here are inflatable module. Yeah, go. So for what concerns the project objective, you see, provide in-field assessment of hybrid inflatable habitat technology. Again, it would be one of the first time this kind of technology would be tried, at least on analog on Earth. A few other examples on Antarctica, but I mean not really focused on let's say Mars. So the idea is provide a test bed, an effective test bed for testing the technology that are there. Lower the risk of the showstopper we saw before. Yeah, just go on. Yeah, these are, again, the list of the main objective. One of the main objectives is also having something that people can visit and then get enthusiastic about the Mars exploration. Again, having a location nearby on touristic area could also have the advantage that you can bring people in, you can show what you're doing, maybe at the same time like a crew is doing something, explain what you're doing, and what we think is that this could be a very good way of inspiring people and scientists and engineers, also because I think in this moment in which there is economic crisis and so on, we need engineers, we need scientists to kind of give a boost on the economy, and maybe if you get, say, young generation being enthusiastic about these things, we can also get a boost in economic terms.
We should just say Edward Snowden's there. Let's see how fast we get there.
We are working very hardly in putting together a complete project for what concerns ERAS. We have tried at least a couple of times European application for getting the money, but as you can understand, you need a lot of money and getting them is not so easy. But we are keep trying and understanding in a way, the way we can fund this project. But at the same time, we are trying to implement whatever would be possible with little money, and one of the first natural candidate is the control system. The control system would need just a little hardware to be available and then some software to be developed on top. And this is what we are doing. So this is the first step of ERAS, is exactly its command, control and communication system that would allow, let's say, to provide all data processing, all the monitoring control of the habitat, all the communication and monitoring of the habitat itself and the crew that would be doing EVA, so mission outside the habitat, and also support all data processing and also host the so-called crew mission assistant. And I think doing analog and having a good crew mission assistant, this could be one of the nicest point of the whole system, because you can really understand in which would be the best way of supporting an astronaut that is doing an exploration mission using, for example, rovers on robot, and this is what all about. We have started working on this system, and we put the foundation of C3 in terms of a distributed control system. So we, again, classified C3 as a classical, let's say, distributed control system that has this fundamental service: communication, online database, configuration database, and logging. Maybe you can have other like alarming and so on. And normally these distributed control systems are grouped inside frameworks that provide you, let's say, all the basic, let's say, services you need. And the pro of frameworks is the fact that development time can be decreased, maintenance can be facilitated, and you spend your time mainly on developing your own functional part, the real control solution you need, instead of reinventing the wheel. So, yeah. We spent some time in understanding what would be the best framework for us, and we look at this selection criteria. And at the end of the story, we came out with Tango. Tango is currently used mainly for synchrotron, big synchrotron control application. So it has already a large use base and it's been thoroughly tested. And considering this selection criteria, we saw that could fit our need, and we are currently using it and basing our development on top of it. So this is the functional diagram of C3, and I let Ezio go into detail.
Yeah, so this is where Python actually comes in, because these are like some of the things we are planning to do. So we have, for example, communication with PLCs, we have communication with spacesuits, with rovers, with satellites, and actually, yeah, can you hear me from here? Yeah, so I don't need the microphone. Okay, so, and we also have like with space probes, and everything, like every block you see here is like a different server that, and they all talk with each other using this Tango framework. So this framework allows us to write servers for each of these things, and we can do it in Python, and this is what we are doing. It also supports like Java and C++, but clearly we are using Python. And we can make on this server, and we already made some of them. And we also have this crew mission assistant that, maybe can I say that is some kind of AL 9000? Yeah. It's like some, it's basically, it makes like, for example, if it sees that there's like some solar activity, so there's like a risk of solar storms, then it makes a prediction. We use like neural networks to make predictions, so we can figure out where there might be a problem, and we warn the astronauts. Or even if the values of the, for example, the earth beats, or the oxygen level, or all these kind of things. So this is what we do here. So yeah, this C3 system will take care of all these things. So it will monitor the habitat, so like the temperature of the habitat, the humidity, if there are leaks somewhere or like some emergency, and not only for the habitat but also for the crew members. So if all the vital signs are good and in like normal range, And it will also allow us to communicate with the several like machinery that we have there, like with the rovers, or even, I don't know, you can imagine like you can regulate the temperature like remotely. If you want to raise the temperature in the greenhouse, you can do it from whenever, or even like controlling the rover. We are actually doing like some project about the rover. I will tell you more about this later. And also communicate with space probes, so we can get data about the environment. So both like satellites, but also like meteorological station. And this is like the AL 9000 I was talking about. It can like make prediction and detects values that are out of range and warn the crew about all these problems. So we already start doing like some real world tests. There was one in Dutch Spain in 2012, and last February we were in Eastbrook. There was like this Morocco field test. So basically there were an actual crew with spacesuits and everything, and all the machinery doing a simulation in the desert of Morocco, because the environment is kind of similar to Mars. And we were in Eastbrook. We were like the mission control on Earth, and we were like communicating with them. So what we did, we were getting data from the Auda X spacesuit. It's like a prototype designed by the Austrian Space Forum. Yeah, and this is what we did. We were like reading data about the Earth rate and the physical activity. So there were like accelerometers on this spacesuit. So we were saying like, okay, now the astronaut is standing still, but this Earth is beating too fast, so maybe there's something wrong with it. Or if it was moving, then it was okay. And we were using neural network. We were just like trying out a bit, like see if it's possible to get the data and make prediction. And we made like some tests, and it was working fine. And also we were getting data from this Unveyor, which is like a space probe that it basically can get data about the temperature, humidity, wind, and these kind of things. And so even here, we were like getting data. We were also using Redis. Also, this is like from an Hungarian team, right? And we were also using Python, so that was like really convenient. We were using Redis, so we were just like reading all the data from the space probe, and we were using them like inside our framework. And this summer we applied as Mars Society for Google Summer of Code, and we are going to work like through the summer on these 4 different projects. So I'm actually one of the students, and my project is about rover control using EEG Neuro headset. So the idea is that since you want to control rovers when you're out into Mars, like on the Mars surface, wearing a spacesuit, you cannot just use a joystick or like maybe drive or control the rover, because we have also like small and big rover. So the idea is like, how can you control the rover and be hand-free? And this is something we are exploring. We have actually 2 projects. There's another student that is looking at the speech recognition. So you can send command to the rover, say like, go there, pick up that stone, dig a hole there. Or what I'm trying to do is see if this is feasible also using like reading brainwaves. So by using thought, you can just push the robot, like tell it where to go, and we want to find out if it's feasible, if it's like accurate enough, and if it will work. We also have other 2 students, and this is a project I started last year when I was at the Mars Desert Research Station. So I was reading data from a satellite, the GOES satellite, about solar energetic proton events. So basically the level of radiation, like the solar activity. And this student is continuing what I started by adding the prediction. So he's also working with technologies that allows you to predict if there's going to be a storm. And this other student is working on the spacesuite, so also what we started in Innsbruck. So making prediction about what the data of the vital signs of the crew members are like, if we are in normal range or if there's some value that is off, and it even predict if something might get wrong. So this is what we are doing, and yeah, actually we're like one of the students that even if it didn't manage to get into the program, he just joined for free because it's like really cool projects, and he just like join even if he doesn't get paid, and that's like great.
Well,
and
I just want to add one thing.
Yeah.
I mean, this solar energetic proton event prediction is something that at the moment is not very reliable in general. This is another example of how technology would develop for exploring Mars would be useful for the Earth. In reality, you should know that, I mean, solar storm also generate problem on Earth. Until now, we do not have a good prediction of it. So this is something that is not, we are doing it, obviously, for this project, but our idea is that if we come out with something usable, obviously we will make it available to the community to do real, let's say, solar storm prediction. That is something, again, as I said, there is no good prediction till now, and we are hoping to use, let's say, a machine learning technology to get out something, and if we do, let's say, whatever we put available, we will put everything available on our website and publicize around and say, okay, we do have something reliable, please use it. So you see, again, as in other cases, space exploration technology has always, I mean, pushed terrestrial technology, and this is always something we would like to point out.
Okay. And we also have like a plan for this summer, but we are not just going to stop after this. We are just like start exploring all the possibilities, and our work will continue. We hope to collaborate with, for example, the Austrian Space Forum, because, for example, reading the data from the spacesuite can be done with an embedded computer that stays inside the spacesuite. So it can get the data in like immediately and see immediately if there's something wrong. So we were like looking at embedded devices, and we hope to collaborate with other space forums and other associations. And also another important thing is that we are doing everything open source, so you can find the code on Bitbucket. You can just like make a clone and try it yourself. You can contribute it, you can test it, you can even make patches if you want, or add new server. And we are also using read the docs. We have like some basic documentation, because we actually started this project just like last week, kind of. It's like because first we were just like experimenting a bit. Now we are making it official. We are making all the main software repositories, start writing documentation, start making more usable for everyone. And we are using all open source solutions and make it all open source.
And by the way, we could say that here we are mixing Waterfall Classic and Agile, in the sense that, as you see, we have template for what concern the software requirement, software design, and so on. So we are trying to mix the two techniques. And also we have a big weekly, let's say, report that are similar to having milestone every 2 weeks in which people are saying what they are doing. So we are trying, obviously, to use a mixed technology, mixed methodology, also because the team is really spread all over the world, in India, Germany, United States, and Italy and Finland, indeed.
Yeah. Okay, so this is like a few of the libraries that you're using. As I said, everything is in Python, and we use Pytango, which is like allows us to use this framework. And we are also using like this library to make predictions. And for the neuro headset that I'm using, we have this EmoKit, which is like an open source Python library. So we were also lucky, because wherever we were looking at, we will find a solution, and it was always in Python. So we had no problem. And we also have like a small rover that is kind of working. We did some tests this weekend, but it's currently not working. But I found like a C++ library. I converted it to Python in a couple of hours. And now, if it works, I'm going to show you a quick demo. I'm not sure if it will work, but we can try. So this is the Neurad set I'm using. is like an emotive epoch. You can get one of these for $300. It's not really expensive. And one thing I should say is like, since we did this over the weekend, I cannot read the brainwaves yet. So this also has an accelerometer, so now I will kind of cheat and just use the accelerometer, assuming it works. But the idea is that you can also use, like actually reading the brainwaves. The problem is that it takes time to convert brainwaves in some actual usable thing.
Think harder.
Yeah. So now if I can, okay, and I need, so just put this together like in 15 minutes. So, and I really hope it will work. Is it here? Okay, so I'll make it run. I don't know what it will happen. So.
You go on the web and search for Apple, and you will find Apple, or emotive.
Okay, so you see something? Yeah, so now I cannot see what I'm doing because I can. Okay, so this is our simulation of Python on Mars. So I can just, with the accelerometer, I can send Python around. And you can see it's quite accurate. If I want to reach this stone here, or even this stone here, or even that stone there. So this show you like a quick demo that I put together in 15 minutes. So,
No,
but
as Ezio was saying, so
yeah.
we would like it to use for the final thing. So
yeah, so this was just like to give you like, just to have something cool to show, but this is not our final project. This is, we are actually thinking about making an actual better simulation, because since we don't have an actual rover, we have like some small prototypes. So the idea is like, we just make this one, and we make a 3D rover on a 3D landscape, like a video game, and then you can just control the rover and also train astronaut in a virtual environment. And the cool thing is that all this is software, so whoever has a PC can write it. You don't need like a lot of money to like buy like rover or build like equipment. So you just get a small initial expense for this, and then you can just write all the software you want, and the software is what will actually go on Mars. It's something that is like real, it's not a prototype. Okay, so I guess which...
I don't know, if you happen to be in Boulder, Colorado, in between the 15th and the 18th of August, there will be the Mars Society convention there, and we hope to do a much cooler demo there with Epoch using brainwaves and then a small rover going around. So if you come, you will see a nicer demo.
And I have a link? Yeah, okay. So this is the end of the talk. You can see here. And you can find more information here. Questions? Okay, we have.
Exactly saying that. For all the problem, we decided to enlighten a little the talk, so we still have 10 minutes for questions.
Yeah. Or we can also catch at lunch if you have more questions, and there's no time now. I mean, do some. Yeah? Just keep it.
Okay.
Yeah.
There we go. Thanks for the talk. It was really interesting. You've promised to share your technology with Earth, but how do we know that when you get to Mars, you aren't just going to use it to start a war with the Terrans?
Well, the technology is like open source, so everyone can use it, and yeah. So we are all on the same at the same level, so that's not a problem.
Thank you. Really great talk, actually. A bit of a side question. Have you heard of the Mars One project?
Yes.
And what are your thoughts about it?
Okay.
we are going to approach them in few months from now and ask them to collaborate and propose to them that what we are building here become the virtual environment in which their astronaut can train to. So this is the final goal here, is being able to put together also, again, if you think that maybe you put together everything and part of it can be completely virtualized, and maybe you can have, the other step we would like to do, I don't know, is using 3D glass, for example, and integrate this technology to what we are doing here. And again, exactly the point would be, please, we do have a complete, since we cannot yet offer the physical ERAS station, we are going to offer around a virtual ERAS station that we can build without big funds, without big money, and we are going to offer it to other organizations like Mars One.
And also we are looking at like some cool gadgets like the Oculus Rift. I don't know if you ever heard of it. It's like some 3D glasses that gives you like a virtual reality experience, or even some like Google Glass. We are like kind of exploring like how these things called like if they can be used even like just for simulation, but if something similar can actually be used on Mars. So for example, the Neuro headset is something that could be integrated in the spacesuit. So you don't have to wear that, it's like integrated in the spacesuit and is reading your data. So we are also exploring this kind of like possibilities. Other questions?
Yeah, thanks for the interesting talk. I have a question on the radioactivity issue. What would you like pick up in a week on Mars when it comes to the rates in grays, and what is preventing you from using lead? Lead.
Wait. The idea is that the radiation shielding you have to deal with, you have to create must be useful for you during the travel, and also useful for you once you are on Mars. So you have to bring it. You need to be protected while you are traveling. And this is the most important thing, because this is the most delicate time. And if you can just put together around your space capsule, for example, your water and all your waste out of your water that are protecting you. Basically, the idea here is that for this water wall, the brines generated by recycling your urine will be protecting you against radiation. So that's the idea, for example. So again, you cannot use lead just because it's too heavy, and instead, you cannot afford to bring with you something that would just do only one function, and is very heavy. That's the idea.
Yeah, you can just build a bunker on Mars, like by bringing there like loads of lead. Okay.
Hi. My question was, can you hear me now?
Yeah.
My question was about the Curiosity Mars rover.
Yes.
What you're doing, is that also collaborating with Curiosity, or?
So we are not collaborating directly, but one thing, like we were looking, because they provide some data like openly on the web. So one of the projects we were looking at was like getting this data and writing a server that we can use in our system to actually use this data and make them available. It's something that we are exploring, but as I said, there are like many possibilities, and there's just like a few people right now, so we haven't done that yet, but that's something definitely we would like to do. Okay.
Hi,
okay.
Nice talk. I was surprised that you want to use brain-computer interfaces, and I would like to ask you which software will you use to analyze the brain activity?
So right now we are kind of starting from scratch. So my next step will be like to read the raw data from the headset, and then I will see, like the idea is like writing the software myself, but I also look at some possible software. The problem is that there is some software for this headset, but you have to pay for it, and it's like quite expensive, and it's not open source. So there are, I've seen like a few alternative open source software, but there's nothing that is like, that it's like perfect for it. So it's something that I will have to look at. But the plan is like if I don't find anything that works, I will probably do it myself.
Have you had a look to buy VCI 2000?
I don't think so.
Okay, so that's a free software done in Python. And then second question is, why do you go for Epoch?
Just because it was like one of the cheapest one that we could found. Because this isn't actually, I mean, this is just like to see how feasible it is. This is not probably the final product we will use. We were just like trying out to see like how far you can get with this one. If it works, then we will invest in maybe something better, something more accurate. And but this is just what we found look like a good compromise between price and functionality.
Okay, and
you can say that if you look at the literature, there are more and more use of this device, in the sense that people, I mean, scientists especially, were skeptical about this. But if you look at more recent papers, there are papers that are coming out, scientific papers on the use of this.
Because the reliability of this device is not that good as another.
I know, for us it was basically the only compromise we could get. I mean, for $300 you cannot get much more, but I'm surprised myself of what you can really do with it. And sure, it's, especially at the beginning, for a single command is very easy. You can really, I mean, with your thought, I mean, do a single command. Two, it's already, but the idea is that with some training you may be able to do something. But anyhow, with the let's say training suite that come together with the device, it's already kind of surprising what you can do.
And do you know of more groups of people that they are working with VCIs applies to Mars or like outer space experiments? Or?
The things I've seen till now, it's there are many different uses. Some of them related to the relationship with the robots. That is very similar to what we are doing. In our case, we are focusing, let's say, rover and robots that may help you, especially because you are in a situation that is very similar to impaired people, like the classical application would be, people on a wheelchair or these kind of things. While you are on Mars with the big space suite, you are similar to an impaired people. So for us, this is an interesting exploration, because we think that you need to augment as much as you can the possibility to command and drive. I also believe that we will get interesting result from the voice command. So we are trying to do it the best way we think, and the student Eric that is working on that seems the perfect guy. He has a background also on say speech and linguistics, so I think it's the perfect person that can do these things.
Concerning weight, are you evaluating 3D printing on Mars? Just not to carry all the...
Yeah, 3D printing is also something we're exploring.
In 2 weeks we will have a 3D printer that is coming to our premises in Bergamo, and that we will be using for this kind of things, like say, since I don't want to bring with me everything, and we are going to start. We need first to have our hands on the 3D printer, and then on the ERA site, Mars.
Thanks.
Any more questions? Do we have time for more?
In which way you could do it? In which way you can